Our lecture, chapter 4, oscilloscope. I have uploaded this note in Microsoft Teams. Okay, this chapter is about oscilloscope. We will start with theory on oscilloscope and then calculation involved with oscilloscope. Okay, so how many of you never seen oscilloscope? Is there any of you never seen oscilloscope? Ada yang tak pernah? Pernah Okay, so you will learn about basic structure of oscilloscope. And then we will we'll explore on function of oscilloscope and use oscilloscope for a signal and phase measurement or calculation. Okay, so how many of subtopic in this chapter? How many? How many? How many?
12.
Pardon?
4.1 to 20.
How many? So how many subtopic in this chapter? If you look at this slide.
11.
11. Okay. Okay. Just to trigger you so that I know you are with me and listen to my lecture. Okay. This is oscilloscope. It is graph displaying device. Basic instrument for the study of all types of waveforms, also known as cathode ray oscilloscope (CRO). It allows the amplitude of electrical signals, whether they be voltage, current, power, and so on, to be displayed primarily as a function of time. So the y-axis is for the amplitude of the signal, whether it is voltage, current, power, etc. And the x-axis is for function of time. It can be employed to measure such quantities as AC or DC as well. Okay, this is fall time and rise time, delay time. Okay, this is characteristic of oscilloscope. It depends on the movement of an electron beam to impinge on a phosphor surface which produces visible spot. The screen is phosphor surface. It's capable of displaying events that take place over periods of microseconds and nanoseconds. CRO or cathode ray oscilloscopes operates on voltage. However, other physical quantities such as pressure, strain, temperature can be measured by using a transducer to convert the physical parameter to an equivalent voltage. Capable of accepting two or more inputs and display them simultaneously. Okay, this is the front panel of oscilloscope. You can watch the YouTube video. Okay, that explain the function of each component on oscilloscope. A is the display. So this is the screen or the display. This can be a phosphor screen or an LCD. 4 is the intensity of the trace. Want to speak something? Otherwise, you may mute your audio. 4 is the intensity of the trace. Okay, so when we turning this up increases the brightness of the trace, and turning it down make it dimmer. So we can adjust this knob to make it brighter or dimmer. The focus control 5 sets this. Number 5, to focus the signal, okay, make it clearer. 7, control the position of the trace. Number 7. Okay, so this is Y position, meaning that when we adjust this knob, we can control the position of the signal, make it up and down. Okay, Y position, meaning that we can adjust it, we can adjust the signal to make it up and down. 13, the channel 1 signal input, and 14 is the channel 2 input. So this is 13 and this is 14. Okay, 13 for channel 1 and channel 2. So if we want to display one signal or one waveform on the screen, so we can use only one probe. This is probe, oscilloscope's probe. This end will be attached to this point. Okay, so this is for channel 1. This is for channel 2. Okay, so if we use only one probe, or we want to display only one waveform here, so we just use either one, channel 1 or channel 2. So this end will be attached to this node number 13 or 14. So if you want to display two waveforms, we will have two probes, one at 13, another one at 14. The position of the trace from side to side controlled by 17. 17 is for X position. So we can adjust the signal or the waveform, make it right or left. Position at X axis. This is main components in CRO. Number 1, cathode array tube. It is a tube, okay, like a tube in conventional TV. Number 2 is vertical amplifier. Number 3 is trigger circuit. Number 4 is sweep or time-based generator. Number 5, horizontal amplifier. Number 6, associated power supply. Number 7, delay line. Phosphor screen, electron beam will move in this cathode array tube. Horizontal deflection plates. There are 2 plates of horizontal deflection and 2 plates for vertical deflection. Electron gun here. This is a working principle of CRO. When signal is to be displayed on screen, it is applied across the Y plates of CRT, cathode ray oscilloscope. But to see the waveform or pattern, it is essential to spread it horizontally. This is achieved by applying a sawtooth voltage wave to X planes. Therefore, electron beam would move uniformly from left to right, graphing vertical vibration of the input signal versus time. Due to the repetitive tracking of the view waveform, the continuous display is obtained. Okay, this is the function of each component in CRO, cathode ray oscilloscope. CRT is cathode ray tube. This is CRT. Okay. It emits electrons to the phosphor screen to display a signal. So electron from electron gun will be moved until the end of phosphor screen. Vertical amplifier, a wideband amplifier used to amplify signals to be viewed in the vertical section. So amplify meaning that make it large. So a wideband amplifier amplifies signals to be viewed in the vertical section. Number 3, trigger circuit. Trigger circuit is here. To convert the incoming signal into trigger pulses so that the input signal and sweep frequency can be synchronized. Number 4, switch generator or time-based generator to generate the sawtooth voltage required to deflect the beam in the horizontal section. So vertical amplifier and delay line involved with vertical deflection or vertical section. Okay. The bottom one involved with horizontal deflection or horizontal section. Okay. Okay, if we look at the connection, so vertical amplifier connect to the vertical plates, while this component is for a horizontal plate, so they are connected to horizontal plates. Horizontal amplifier here to amplify the sawtooth voltage generated by switch generator before it is applied to horizontal deflection plates. Power supply to provide voltage required by the cathode ray tube to generate and accelerate the beam. Delay line to delay the signal for some time in the vertical section. So the vertical signal go through this line, okay, but it will go through the horizontal section. So delay line will delay the vertical section so that it will reach here together with vertical section. Okay, this is CRT, cathode ray tube, this one, the middle part. This is the most vital component in an oscilloscope, which is very much similar to picture tube in a television set. This is conventional television where we have a tube in the TV, okay, like this. Okay, this is conventional television where we can see the shape of CRT. So this is CRT in television, okay, cathode ray tube. This is CRT in oscilloscope. The CRT makes the applied signal visible by the deflection of thin beam of electrons. Oscilloscopes depends on the movement of electron beam striking the fluorescent substance. Fluorescent substance is the screen, coated screen, which then produces visible spots. Okay, beams are deflected on both x and y axis, producing output of time-dependent variation of input voltage. Okay, you can watch the video of cathode ray tube construction. This is for CRT only. Okay, cathode ray tube. This is the main component in oscilloscope. You can watch this video later. Okay, electron gun. Okay, still in CRT. In CRT, electron gun is one of the important components. It produces thin electron beam which the electrons will strike the fluorescent coated screen. Okay, this is a phosphor screen, causing the point of collision to glow brightly. The beam is deflected by electrostatic or magnetic field and cause the spot to move accordingly and traces out a pattern. The brightness of the phosphorescent spot depends on the electron beam. The more the electrons striking the screen, the brighter it is. More electrons mean more current needed. The negative bias voltage applied to the control grid controls the beam current. The intensity is greater. Okay, this part is for focusing the signal. Okay, you can read by yourself. Horizontal and vertical deflection. By referring to simple CRT diagram, when H1 is made positive with respect to the cathode, it attracts the beam and the spot moves horizontally to the left and vice versa. Horizontally, This one is for vertically. Similarly, when the V1 is made positive, the spot move vertically upwards and vice versa. In each of these deflections, the displacement of the beam is proportional to the voltage applied to the plates at the place. Okay, this is phosphor screen, the screen of the oscilloscope. The cathode ray tube emits electrons to the phosphor screen internally to display signals. The screen is coated with fluorescent material called phosphor. This material determines the color, which normally for oscilloscope blue, green, or blue-green. Okay, so the waveform display on oscilloscope usually in blue color or green color. The material also determine for the trace resolution and trace length of time to remain visible after the signal has ended. Okay, you can read by yourself. These are the detailed explanation on each component of oscilloscope. Trigger circuit, sweep or time-based generator, horizontal amplifier, delay line. When the delay line is not in use, the initial part of the signal is lost and only part of the signal is displayed. Okay, so the main function of each component is in oscilloscope can be found in earlier slide. Okay, this slide. This is the brief explanation on function of each component of CRT. We have 7 main components of CRO. So you can read this main function of each component. Okay, so the beginning part of this chapter is theory. This is probes. There are 2 types, passive and active probe. Passive is mostly used. It may provide one-to-one, meaning that this is the ratio of signal coming to the oscilloscope. Okay, 1 is the signal display on the oscilloscope. So the same ratio, 1-to-1. Okay. Active oscilloscope has active components incorporated within the probe itself, enable greater levels of functionality and higher levels of performance to be attained, much more expensive and normally reserved for the more exacting or specialist requirements. Okay, one time probe is for direct probe, meaning that 1-to-1. Let's say the signal comes from the circuit is 1 volt, then when we want to display it through the oscilloscope, the display or the waveform on oscilloscope also show 1 volts. Okay, direct probes. 10 times scope probes, meaning that probe will scale the signal 10 times smaller before it enters the oscilloscope. Same goes for 100 times. It will scale 100 times smaller before it enters the oscilloscope. Okay, these are the explanation on each probe. Okay, now this is part of calculation. Application of oscilloscope. Number 1 is for voltage measurement. Number 2 is for period and frequency measurement. Voltage measurement, it can be current measurement, power measurement as well. Meaning that for amplitude measurement, amplitude of the signal, measurement of the amplitude of the signal. It is y-axis. Number 2, x-axis. Okay, so let's say we have 2 signals. We have two signals, the green and the blue one. Okay, so how to calculate the amplitude of the signal? Okay, so voltage per division multiplied by number of division. Okay, so the voltage per division for this signal is set on 100 millivolt per division, meaning that for each vertical division, one division represents 100 millivolts. Okay, time per division meaning that horizontal division is set for 0.5 millisecond per division, meaning that for each division at horizontal axis, one division or one box represent 0.5 millisecond. Okay, so now what is the value of V peak to peak, voltage peak to peak of this signal? It seems like the green and blue signals have the same amplitude. Okay, so V peak to peak is measured from the peak, the top until the bottom. Okay, peak to peak. So we just count how many divisions. 3.8 multiplied by 2. Okay, so this is origin 1, 2, 3, and about 3.8. Okay, and then same for the negative direction 1, 2, 3. Okay, so 3.8. So 3.8 plus 3.8 or 3.8 multiplied with 2, we get 7.6. Okay, 7.6 division. Okay, number of division is 7.6 or 3.8 multiplied with 2 and then multiply with the setting. Okay, the setting for vertical axis of volt per division is 100 milli. So multiply with 100 milli, we get 0.76 V. So peak voltage is equal to 0.76 divided with 2. V peak to peak divided with 2, it is 0.38 volts. Okay, or we can calculate like this, 100 milli multiplied with 3.8. Any question? Any question? Any question, class?
So far, no.
No question. Okay. Okay, the second one is for period and frequency measurement. So how to calculate period? Period is calculated from for one full cycle of the signal. Okay, complete cycle. The period is calculated as time per division. This is the setting for the signal. Multiply with number of division for one cycle. So one cycle can be considered as from 0 until 0. Okay, so from here until here, or from peak to peak. Okay, or from the bottom peak to the bottom again. Okay, so for one cycle, so the setting or the time per division for the signal is 1 millisecond per division. The volt per division for the signal is what? Okay, not given because we want to calculate the period only for this example. Okay, so the period for this example is if you calculate there are 16 division from 0 until 0 again. There are 16 divisions. So 16 multiply with 1 milli, we get 16 millisecond. Okay, so the period for this signal is 16 millisecond, and then we can calculate frequency. Frequency is 1 over period. 1 over 16 milli is equal to 62.5 hertz. Okay. How about this signal? How many divisions here? 1, 2, 3, 4. Okay, 4 divisions. So 4 multiply with 1, we get 4 seconds. Okay. How about the middle? There are 1, 2, 3, and about 4. Okay, 4. So 4 multiplied with the time per division is 0.5. We get 2 seconds. Okay, the period for this signal is 2 seconds. How about this? 1, 2, 3, 4. 4 again. Multiply with 1 milli, we get 4 milliseconds. Okay. The frequency is 1 over period. 1 over 4, we get this. 1 over 2, we get 0.5 hertz. 1 over 4 milli, we get 250 hertz. Any question?
No.
No, sir.
Okay, the next is how to, okay, basically there are three main calculation for oscilloscope. Okay. Calculation of amplitude, calculation of period and frequency, and the other one is the calculation for phase difference. Okay. Okay, let's say we have two signals, the red and the green one. Okay. Now we want to compare now we want to calculate the phase shift or phase difference. Phase shift or phase difference between two waveforms. Okay. Only for two different waveforms with the same frequency or time can be compared. Okay, so when we want to compare two signals, the period, okay, the period for these two signals must be the same. Then we can compare the signal, or we can have the phase difference or phase shift. Okay, so the phase difference or the phase shift is equal to a number of division of phase shift divided with total division for one cycle. Okay, multiply with 360, so we will get the degree. Okay, the phase, okay, the phase. Okay, division divided with division. This one is for phase shift. This one is for division for one cycle. Okay, so this is phase shift. Total division can be calculated as one signal, one cycle, full one cycle. Okay, you can watch the video on basic diagram of CRO, CRT, measurement of voltage. Okay, so this video also shows measurement of voltage, frequency. Okay, voltage and frequency. Okay, this is usages pattern that will be covered on this Friday or next week. Okay, now we go to tutorial 4. Okay, tutorial 4 number 3. Okay, number 3, 3B. For the display in figure 3, the vertical amplifier control is set at 0.05 volt per cm. Okay, meaning that one division is 0.05. This is for vertical amplifier, or this is for volt per division. And the sweep is 0.02 millisecond per cm, meaning that this is time per division. Find the amplitude Vm, okay, Vm, the amplitude and the frequency. Okay, no, okay. Let me change the equation. So this frequency, not omega, okay, not angular frequency omega, but find the frequency of the sine wave, only the frequency. Okay, find it now. Try it now. Anyone want to try? Anyone want to try? Anyone want to try? 0. 0.11 and 12.5 Hertz. Zero point one
Dapat sama itu.
sama. Okay. Okay, class.
Doktor, mic doktor.
Sorry, how many division on vertical axis? Abdul Aziz, Ahmad Yusuf. Please answer. Abdul Aziz, are you with me? Abdul Aziz? If you cannot respond to me, so consider as absent. Abdul Aziz? Okay, no response. Siapa lagi? Duhair, how many division on vertical axis? How many? Duhair?
Yes, doctor.
How to calculate amplitude for this signal? How? How to calculate? Duhair? Very simple calculation, very basic calculation. Okay. We go back to Abdul Aziz. Abdul Aziz, how to calculate the amplitude for this signal? No response. Mana lagi? Mushfiqur Rahman, how to calculate the amplitude for this signal?
Hello, doctor.
How to calculate?
I think I didn't get it yet.
Why? This is a very basic calculation. If you pay attention to my class, you can answer. Okay, because chapter 4 is very easy calculation, okay, compared to other chapters. So that's why I spent this time to test your understanding. Okay, I don't know. Muhammad Omar Al-Atas. Okay, how to calculate the amplitude of this signal? Omar Muhammad.
Yes.
How to calculate?
The division.
How to calculate the amplitude? Find the amplitude. How to calculate the amplitude?
You have to أحسب.
Don't know. Okay, meaning that.
Calculate the box and the wave.
Okay, so how?
There is four square in the wave.
Okay, and then how? How to calculate the amplitude?
By
Don't know. Not sure. Right.
yeah.
Okay. Now we pick other student. Fatrun. How to calculate?
Yes, madam.
How to calculate the amplitude?
Saya kira duration vertical tu. Lepas tu darab dengan 0.05 kan.
Okay, so how? Give.
Tapi saya tak pastilah kalau yang ni 2.5 ke 2.5 ke
Okay.
2.4 ke 2.
Okay. Let's say 2.5.
So 0.05 multiply by 2.5.
Okay, so the answer is VM, right? V maximum or V peak. Okay, so 1, 2, and about 2.5. Multiply with 0.05. Now, what is the value of peak-to-peak amplitude or peak-to-peak voltage?
Multiply by 2.
Omar Muhammad, what is the value of peak-to-peak voltage?
Yes. Multiply by 2. B multiply by 2.
Okay, give me the answer.
I don't have a calculator.
What multiply with what?
VBIC multiply by 2.
Okay, and then you get?
You get VBB.
Yes, what the answer? What is the answer?
I don't have a calculator.
Don't have the calculator? Come to my class and you do not bring your calculator. Huh? We will involve with a lot of calculation. So make sure during class, please bring your calculator. Put it beside you. 0.25 volts. Okay. So how to find frequency of the signal? How to find frequency? Let me call Sami Abdullah Saleh. Give me how the step to calculate frequency, not the angular frequency, omega, but the frequency, F. How to calculate the frequency? Sami?
Yes, doctor.
How to calculate the frequency of the signal?
Okay, now I will calculate it.
Okay, never mind. Just let us know how to calculate.
Doctor, it's 7,800 rod by each second.
Again,
7,8
7, 8.
W, the W regular frequency equal to W 2 pi over T under T.
Please type, Sami. Please type here. How
Okay,
to calculate?
okay.
Please write how to calculate. Okay, not only the final answer. Write how to calculate.
Okay.
Faster. Faster, how to calculate. Just write the value, what multiply or what divide with what, and then equal to what. What is this? 2b. Find the frequency, not the angular frequency. The frequency only. How to calculate the frequency? Sami? Are you with me, Sami?
Yes, doctor.
Okay, please write here how to calculate the frequency. What is W?
Okay, doctor.
Arif Afifi, how to calculate?
Calculate apa doktor?
Apa? Frequency?
1 bahagi dengan number of division.
That's all.
Yes.
1 over number of division, and then you get 1 over?
1/4.
That's all. Ramona, is it correct?
Tak.
Habis tu, how to calculate?
Frequency 1/T.
Yes.
Then find the T first.
Yes.
Time per division times number of division per one cycle.
Okay, and then please proceed. Time per division is equal to?
Is equal to 0.02 times 4. 0.08
0.02 milli.
milli.
Okay, milli. And then multiply with
4.
because of 4 divisions, right? 4 divisions at horizontal axis. Okay, it is represent one cycle, full cycle. Okay, and then we get period, right? Frequency is equal to kejap. So frequency is equal to Abdul Aziz Ahmad Yusof. Abdul Aziz Ahmad Yusof, are you with me? Or only your laptop with me? Where are you? Abdul Aziz can be considered an absent because I call his name 3 times and no response. Okay. And then the answer is Aiman Firdaus. The answer of frequency is equal to Aiman Firdaus.
Doctor, can I answer?
Yes.
Equal to 12.5 hertz.
12.5?
Yes.
Okay, the unit 12.5 what?
Hertz. You mean the frequency?
Again, 12.5?
Hertz.
Okay. The answer is 12.5 kilohertz. Okay, if you ignore milli here, your answer will be no kilo. Okay,
Okay.
we have milli and then milli here, your answer will be in kilo. Okay, the next, number 4. Determine the pulse amplitude, meaning the amplitude. The amplitude of the signal. Frequency. Okay. Time rise. Time rise is this. And fall time of the waveform shown in figure 4. Okay. Now please calculate. Okay. I give you about 5 minutes. Please calculate. I will pick any name. No answer meaning the absent. Okay, no response. Okay, if you give wrong answer, it's okay, but if there is no response, meaning that absent.
Doktor tunjuk soalannya, Doktor. Doktor. Dengar.
Kejap. Okay, ya.
Yang tu macam nak tengok dia time division ni. Dengan word.
Ni. Okay, so this is the setting, okay? This is the pointer of time per division and word per division. Understand? Okay, so what is the value of amplitude, frequency and rise time? Okay. Okay, get the answer. Omar Muhammad, what is the value of amplitude? Omar Muhammad, what is the value of amplitude?
I can't.
Omar Muhammad, you are in year 1.
Yeah.
You are in year 1 or year 2, year 3, year 4? Year 1.
Year 1.
8 volts. Abdul Aziz. Okay, so the answer is 8 volts. Mushfiqur Rahman,
Yes, doctor.
what is mic? Abdul Aziz. I have in my mic. What is this? Cannot understand. Okay, Mushfiqur Rahman, how to calculate? How to get that 8 volts?
Ma'am, it's the highest value of a signal. Peak.
Okay.
Peak.
How many division? How many divisions? For
2.
vertical? How many divisions for vertical axis? Rahman is in year 1 or what?
Yes, ma'am. It's year 1, sem 1.
Sem 1. Okay. Zuhairi, how to calculate the voltage?
Yeah, doctor.
How to calculate the voltage?
Saya dapat 2 times 2, 4.
2 times 2, 4. Again?
Voltage saya dapat 4.
Peak voltage or peak to peak?
Voltage P to voltage P.
Peak voltage?
P to P.
Peak. Peak to peak.
P to P.
Okay, how to calculate?
2 times 2.
Okay. How many division?
Division.
Division is 2. And then volt per division is 2.
2.
Okay. 1, 2. Right.
Yes.
Okay. But that is peak voltage. Okay. Peak to peak voltage is 1, 2, 3, 4. 4 multiplied with 2, we get 8.
8 volt.
8. Okay. So peak voltage is 4 volts. Okay. Amplitude is equal to 4 volts. Peak to peak is equal to 8 volts. Peak voltage is equal to 4 volts. Okay.
Okay, doctor. Thank you.
Akmal Rakin. How to calculate the current? Sorry. The period. How to calculate the period?
قول لي بس هات.
Akmal Rakin. Akmal Rakin.
Doktor, volt per division dia setting dia bukan mili bukan dalam mili.
Yang milli is here.
Oh, okay.
From here to here.
Okay.
Okay. The upper side is V. It depends on certain oscilloscope. Okay. So we based on the figure. Akmal Rakin, how to calculate period. How to calculate period? Mana Akmal Rakin ni? Ada?
Ya, dia ada.
Ada tak?
Ada.
Okay, how to calculate?
Good full 1 cycle.
Apa dia?
Tak pasti ya tu.
Hai. Tadi tidur ke apa?
Ada.
Azdu tak faham ke faham?
Kurang sikit.
Habis you did not ask me. Shy. If you cannot understand, you can directly interrupt me. Okay, ask me which part you did not understand. Daniel, how to calculate period of the signal?
First cari T dulu. Dia
Period. Okay.
So dia punya yang untuk vertical ni horizontal ni dapat 6.
6. 1. Okay. Macam mana 6 tu? 1, 2, 3, 4, 5. Are you sure? You get 6?
No, bukan. Dalam 5 point.
Faster. Daniel.
Dia kira ikut by kotak kan doktor kan daripada first ni.
But you should know where the signal start. Okay. You can refer to, okay. Let's say you want to pick origin. Okay, this line. So the signal will start here, not from the beginning of the box. Okay, it start at 0.2, right? 2, this is 0.4, 0.6, 0.8, this is 1, okay? And then it start here, okay, so this is the signal, it ends here. So you will calculate, you will count, this is one full division 1, 2, 3, 4, 4 plus 0.8 and 0.8, right?
Betul.
So you will get
5.6.
5.6 and then what to do?
Darab dengan time per division.
Okay, what's the value? What's the setting?
5. Tapi sini micro. 5
5 micro. Okay, 5 micro. And then you will get the period, right? Okay, same goes for time, rise time and fall time. Okay, so what is the value for rise time and fall time? Takif ke Sakif ni?
Yes, betul.
Macam mana nak pronounce your name?
Pronounce my name Takif, betul.
Takif okay. Anak buah saya Sakif. Takif maksud dia apa?
Bijak dan cepat faham.
Bagus, cepat faham ni. Cepat Takif. Rise time and fall time. Mana rise time, mana fall time. Okay, rise time you get?
Rise time I get 3 microsecond.
Betul lah, memang cepat faham. Okay. Fall time?
Fall time pun the same.
The same kan? Okay, because how many division for fall time and rise time?
Since satu division dia bagi 5 microsecond, so setiap senggang tu ialah 1 microsecond.
1 micro, okay. So
daripada bottom ke atas tu it takes 3 senggang tu, so 3 microsecond lah.
Okay, so okay, there is 0.6, right? 0.6 division, right? Not 1, okay, not full 1 division. It takes 0.6 division, right?
Yes.
0.6 multiply with 5
microsecond.
You get 3 microseconds. Same goes for fall time, right? Okay, so yeah, done for number 4.
Madam, saya tak faham lah kenapa dapat 0.6.
0.6 Okay, because fall time and rise time, okay, fall time, it clearly shows to us fall time is this, okay, meaning that from here to here. Okay, so this is about 0.6, 0.2. Okay. 0.2.
Oh, jadinya satu kecil tu 0.2.
6, yes, 0.81. Okay, because one box represent 1. Okay, one division. Okay, so we have 5 apa ni? Senggak apa? I don't know lah. Okay, so 0.2, 0.4, 0.6, 0.8 and then 1. So 0.6 division. So 0.6 multiply with the setting. Okay, time per division. Any other question? No? Tak ada Okay, tanya I, nanti I tanya you. Better to ask me before I ask you. Okay, we go to number 5. Given the household, ini soalan apa? Household of 120 VRMS 50 Hz. if the voltage to the CRT in which the volt per division knob is set to 50 volt per division. Okay, but now it is about 350. Okay, we should end at 4 p.m. right? You may have class at 4, I don't know, but I think we should stop here. But let's understand this question. Given the household of 120 VRMS 50 Hz, if the voltage to the CRT in which the volt per division knob is set to 50 volt per division, how many division of the vertical deflection would you expect from the peak to peak? Okay, so it seems like okay, the signal is in VRMS, so you can how to get the peak to peak. You can get the peak to peak value and then try to calculate or plot on a graph to see how many division to get this amplitude. And then this part, the next sentence is for period. Okay, if the time per division of the CRT is set to 10 millisecond per division, how many cycles would you expect to see on the screen if it has 8 divisions vertically? Okay, so we have 8 division vertically and 10 divisions horizontally. Okay, so the next sentence is for when time per division is 10 millisecond. Okay, so you may try this. Number 4. Let's see the answer. Yes, for number 4, the amplitude is 8 volts. The period is 4.6 multiplied with 5 microsecond, and we can calculate for frequency. The fall time and the rise time is 3 microsecond. Okay, so actually for oscilloscope question in final exam or midterm test, we can accept, okay, your answer a bit, because sometimes people calculate, okay, student calculate 0.6 to be 0.5 or 0.6 to be 0.8. Okay, so we can accept if the figure is not clear like this. Okay, we can accept your answer. Okay, so fall time is 0.4. Fall time, yeah, 0.4. Yes, fall time is 0.4. 0.2, 0.4 here. Okay, cuba letak baris. About 0.4, okay? It is about 0.4. Okay, so you can try number 5 and okay, you can try number 5, number 6, number 7. Okay, 5, 6, and 7, and we will discuss on this Friday. Okay, so this Friday we will start at 3:30 p.m. Okay, 3:30 p.m. because I will conduct quiz for 3 students that have not taken it yet. So this Friday class will start at 3:30 inshallah. Please prepare your solution for number 5 till number 7. Kan? Okay, 5, 6 and 7. Boleh, Badru Amin? Okay?
Boleh.
So this Friday buat nombor berapa?